Well, shall we get started?
Yeah, it's 8 o'clock.
Okay. I think you were going to handle the update slides, right, Jeff?
Yep.
Okay. Take it away.
Welcome to our second Rtgwg meeting, IETF 110. Still virtual, still going. Next slide, please. Please read Note well if you are not familiar with the defines rules of your contribution to IETF. And there are all the BCPs that explain how things work. Please, next slide. IPR disclosure specific to Rtgwg. We always poll IPR twice during draft adoption as well as working group last call. Please note that we won't progress unless we receive IPRs from all relevant authors and contributors to the draft. Next slide, please. We are announcing AD change. Actually, we are not announcing, we are just telling you that it's going to happen. I would like to thank Martin for all the great work he has done while being our AD, and we welcome Alvaro back. Let's review the agenda. First, next slide, please. So yesterday meetings we shared with RTG area, and today we are going to have our regular Rtgwg agenda with Greg starting, and then Mike and Fan and Cheng and Chifang talking about their relative drafts. Next slide, please. Document that in our past working group last call, the policy model has been submitted to ISG for quite some time. We are waiting on ISG. BGP peak draft has been in last call for 2.5 months. Received number of comments. We've seen author replying that they're going to address them. We are still waiting for author to start addressing the comments. Next slide, please. We didn't publish any RFCs since last IETF. The drafts that expected to go into working group last call are QS model, RIB extended. We are looking for shepherds for both drafts. The ILFA draft is ready to go as well, and Stuart Bryant agreed to shepherd the document. Thank you, Stuart. Next slide, please. We recently adopted Service 6 egress protection draft. And last slide, please. Ongoing working group documents are ATN, BGP, and actually, that's it. Thank you. And if no questions, we are ready with the first presentation. Greg.
Yes, thank you. Would you help me projecting?
Yeah, I'm planning to project your slides if I can get it to switch over. I'm going to go to full screen in a moment. So let's see. Video AM. Okay, I think we're good.
Great, thank you. Okay, so integrated OEM. Well, we do have different components of OEM. Usually OEM understood as taking two parts, two letters in FCAP's acronym. So it's a fault management and performance monitoring. Fault management is concerned with their detection of network failure, localization and characterization, and performance monitoring. It's obviously measurement of different performance metrics. Usually it's packet delay, packet loss, but based on that, there are different other metrics can be calculated. Next slide, please. So far, we worked on different protocols for fault management and performance monitoring. And we have learned quite a lot. One of the most broadly used and very successful is bidirectional forwarding detection. And there are a lot of hardware-based support for this, and it scales well. But what we learned is that security is important, but doing security or authentication at 3.3 milliseconds for each packet is very expensive. Extensibility is very important and useful. And we want to minimize the number of OEM protocols that are required to operate networks. So that's one of their main motivations for looking at integrating fault management and performance monitoring under one protocol umbrella. Active performance measurement OEM, and active, this is in definition from RFC 7799 that defines the active as using specifically constructed test packets. At the same time, so at IETF and elsewhere, there are a lot of consideration and work being done for on-path OEM or telemetry information collection that uses data packets marked specifically or arranged specifically to generate information about performance and experienced by the packets. So what are looking for performance monitoring? Usually it's a one-way, but two-way is important. And it needs to be flexible enough to do packet loss and delay measurement separately or in combination. The security is critical, and again, as for their fault management extensibility. Combining these two, fault management and performance measurement, is that integrated OEM, we're proposing to build a lightweight path continuity check, have it powerful and flexible with the performance monitoring mechanisms, provide security option, and make it extensible. Next slide, please. So what we're proposing, this reflects, displays their format of the base control message, lists their fields, some of them are very familiar, and the TLV. So the basic TLV extension includes type field, reserved field, length, and then variable length value field. Next slide, please. One of the very important properties for the integrated OEM is capability negotiation. So what we want to have is, we want to have that both nodes can participate in negotiating their capability and adjust their intervals so that system would not be overpowered by their active test. Currently, what we proposed is are loss measurement, delay measurement, path MTU, and authentication. Authentication is done in extension so that it can be applied as needed basis versus comparing to how it's defined, for example, for BFD protocol. That's if the mode is authenticated, that each and every control message expected to be authenticated. The timer negotiation mechanism is a well-known mechanism used in BFD when each of participants of the test session advertises their interval that it wants to send message and expects message to be received. So that allows balance between parties, peers in the test, and protects it from being overrun or attacked. Next slide, please. Authentication capability. Authentication capability expects to be extensible, and each of their parties advertises what it is capable of supporting. That can be identified based on bit field, and then each of them selects the strongest authentication method supported by all parties, and then can be used. Next slide, please. So this diagram reflects how negotiation for the lightweight authentication is expected to work. So there is a negotiation phase, and then there is an authentication phase. And next slide, please. Authentication uses the TLV extension and includes variable length HMAC field. So the length of the HMAC is something that parties can negotiate during their capability negotiation phase. Next slide. Performance monitoring in the integrated OEM, it's using the constructs defined in RFC 6374, MPLS, packet loss, and delay measurement. And that supports synthetic one-way and synthetic two-way, as well as direct loss measurement, packet delay measurement, one-way and two-way, and we are adding packet MTU discovery using padding TLV. Next slide, please. So their path MTU discovery monitoring operation needs to be more detail specific. We welcome your comments, suggestion, and question. Yes, Rakesh.
While Rakesh is coming up, there's a question from Tony Prenda, not to forget replay protection. A comment, not a question.
Yeah, hi Greg. There is a similar draft in the BFD working group. It's a draft Mirmin BFD extended. How does this relate to that work in the BFD working group?
This draft replaced it.
Oh, okay. Yeah, it's not clear by combining the RFC 6374 and BFD taking pieces from two. Not sure what requirements are being addressed because this was discussed in the BFD working group, and the extensions of control protocol for 6374 using BFD. Um, it wasn't clear what were the requirements that we're trying to address.
Well, I tried to explain it in the first. So first of all, it's reducing number of OEM protocols that needs to be supported. Second of all, why it's around lightweight protocol, because lightweight path continuity protocol support, like BFD, enables us to do many sessions at high interval rate, while the performance measurement does not really require high rate usually. So again, if you look at the document, so it goes into explanation of motivation in more details. I don't want to just read the document here again out loud. But
Yeah, so
there is some interest because in other applications like Rift, we talked about with the community, and it already provides infrastructure that supports path continuity, and it might be a nice feature to complement it with the performance monitoring when system discovers their topology.
yeah, there is work going on in Spring and IPPM. In Spring specifically, there is enhanced P.
Rakesh, you are not, your voice disappeared.
We could, so we could probably present this work in other working group and get the compare with other work happening in other working groups.
Yes, I understand that you refer to SRPM work. I just want to point that SRPM, as I understand it, it's built around STAMP protocol. STAMP protocol is performance monitoring mechanism, and it's quite heavy. So it's definitely too heavy for being considered as a lightweight path continuity. So I really doubt that it was not, okay, it was not designed to be path continuity and perform at high rate, like 3.3 millisecond. And as such, I think it's not the best choice as a base for integrated OEM solution. That's why what we are proposing a different approach to this problem. I think that, and I really appreciate that you're interested in this work, because what we are doing, though we're trying to solve it differently, it's to me, it's an indication that there is an interest and there is a real need to do the to have an integrated OEM solution. But definitely, let's discuss which approach is more practical and realistic.
Chengli?
Yeah. Thanks, Greg.
Do you really do you plan to extend the BFD for the whole thing, like protection, OEM, PM, something like this? Is it correct?
It's yes. Okay, thank you. It's not really an extension of BFD. So what we are proposing here would not be on top of existing BFD. For now, looking more like a new protocol that inherits best features of BFD and mechanisms, like, for example, negotiation using pole sequence and some of the structure, but I would not really refer that as this is an extended BFD, and that's why when we started this work and to remove some confusion, we marked this document as replacing this document that we had earlier and named it extended BFD. So the resulting protocol, in our opinion, will have a lot of functional similarities with BFD, but would not be an extension of BFD per se.
Got you. Thank you. And by the way, we will have another solution called IPv6 ACH, and it will be presented later. Thank you.
Ville?
So you have this algorithm negotiation for security, and that's not authenticated. So isn't it vulnerable to downgrade attack, especially because you have the SHA-1, which is not secure anymore as one of the options. The draft says you don't have to accept no authentication, but at least somebody who could get to the link and send a lot of negotiation packets could downgrade the authentication to SHA-1, so it might be better not to negotiate the authentication.
Well, again, so this is early, and we appreciate comments and recommendations, suggestions. So we're open to discussion. Let's do it on a list, and it will be great. Again, we are comparing with the mechanisms that have been used in so far in protocols, and there are other all based on configuration. So we think that being able to negotiate, because different nodes, parts of the network can be upgraded at different level, is a more flexible approach. But definitely your suggestion of having some mandatory security, that's if I understand you correctly, I think that's probably the right way. We need just agree what is the mandatory security authentication level that has to be supported by all nodes that support this specification.
Jeff?
Hi, Jeff Oz speaking as one of the BFD chairs. It's worth noting that we had long conversations with Greg about could we put this inside a BFD? And Greg in his slides makes a good point that what we're doing is we're leveraging BFD-like mechanisms. The properties that are sort of liked by Greg for BFD is being able to carry information from one system to another in a periodic fashion. We do know that BFD is capable of doing that in terms of its protocol machinery, but we're sort of diluting the core mission of BFD in terms of providing continuity checks at speed. So we did suggest Greg actually leverage the mechanisms from BFD for his new mechanism. So to some extent, to answer Fan's question in the queue, we did discuss putting this in the BFD. It's not a great fit, at least in terms of the core protocol, but we're quite happy to see the mechanisms that BFD is popularized carried into the rest of IETF for other purposes.
Yeah. Okay. Sorry, Chair. I don't know if I'm permitted to ask a question.
Yes, please go ahead.
Okay, so I get a clarification from previous comment. So I also have another question that I see you mentioned the PassMTU discovery and the monitoring here. So I don't know if why if there is any use case that to use a protocol like OEM protocol to do this kind of PassMTU discovery and monitoring work.
Well, normally this task is part of OEM functionality. Whether it's done using on-demand tool like ICMP, or whether it's done differently. For example, there is a proposal in beer, Path MTU discovery in beer, that uses LSP ping extension. So here it could be done either on demand, and I'm kind of like thinking right now on my feet using poll sequence, or it could be done periodically. And in BFD, we do have a document that quite advanced because there is a need from their operators to monitor the path MTU, because path MTU on a tunnel can change in course of the operation. So I do believe that path MTU discovery is a part of function that is OEM responsibility. Of course, it could be done differently, but OEM can be used as well.
Okay, sure. Since you mentioned beer, I also want to have a follow-up question that if all these functions are if the functions of this int OEM will I mean what kind of what data plane do you plan to use this int OEM protocol there? Because you mentioned beer. Is that only in the beer, or what other data plane do you have in mind?
Excellent question. Thank you. I really appreciate you asked the question. For now, so this our goal is first to define the core protocol, and then make it applicable to all data planes. Again, I can point to the experience with the BFD, that BFD successfully being applied to MPLS IP. There is an explanation of using BFD in beer, and this is more of point to multi-point flavor of BFD. So, or it's BFD. There are two RFCs, BFD for multi-point networks. So, and
So
this
I wanted
protocol.
to interrupt here a little bit. We need to sort of close the discussion after Rakesh. So I would say let's you could respond to provide those pointers on the list. We'll let Rakesh ask his final question, and then we'll move on to the next presentation after you've had a quick response to that. Thanks.
Yeah, well, Greg, one comment is that with automation and controller and the SDN are fairly advanced these days. Doing less and less control plane signaling and extensions to simplify the control plane. So I think the simple TWAMP is a perfect example of how controller can be used for such use cases. So here, this signaling extensions a bit going in a different direction.
No, I don't believe so, because the control plane is basically the advantage of STAMP comparing to the TWAMP is STAMP configuration can be done for the controller using Yang-based data models. I don't see that there is anything precluding to have Yang data model for integrated OEM protocol and then use centralized controller to instantiate test sessions, whether proactive or on demand, as operator desires. So I don't see any contradiction between the model STAMP can be used in network automation versus how integrated OEM proposal protocol can be used. So, but yeah, let's take it to the list and continue discussion on the list. I think that will be better for everybody.
Yeah, the number of questions, especially with regards to BFD plus extensions, please send to the list, and I believe Greg would be happy addressing them. Mike? Thanks, Greg.
Hi.
Hi there. I'm working on getting your slides up in full screen mode. Just give me a moment. Okay, they should be stable. Thanks.
You look good. Thank you. So this is a this is a problem that's looking for a solution, which may or may not already exist. The drafts that are grayed out there are drafts that we've been working on for a couple years now under the IETF within the COIN research group. And we as Yves Schouler, Diego Lopez, Dirk Huscher, Xavier Defoe, and myself have been working on a series of drafts to describe this problem of locating and capturing data in a standardized way. And so if you go to the next slide, I'll talk a little bit more about the history of this. But so we've had these we had these documents to describe the problem, and now we have some use cases. And so this is the first time that we're jumping the pond to come to the IETF to kind of describe the problem and see if there's a reason to be able to create a new solution if there's not already solutions that exist. And this did evolve out of a series of edge computing side meetings that we held. And one of the gaps that we identified from these side meetings is edge data discovery. And so our problem space isn't edge specific, but it developed out of being edge specific because it's kind of easier to see the problem in that regard, where you want to find data from edge databases and be able to consolidate it, to find it and make some use out of it. And that data can be distributed throughout the edge. And so if you go to the next slide. So again, the problem that we are trying to define is locating distributed data in a standardized way in order to perform some sort of networking actions. There are ways to find data using AWS solutions. Google has solutions. There's a variety of SQL, NoSQL database ways to locate data. You can have orchestrated container solutions that allow you to locate data, but we're looking for this to be more of a dynamic, non-provisioned way to locate data. And that data may be cached and stored throughout multiple locations, and it needs to be marshaled to be able to feed a particular function. And so to that point is why we've been working on this within the COIN RG, the Computing in the Network RG, to just kind of further develop this idea. Sometimes the nature of the computation is determined on the fly based upon context, and which algorithm to perform can be an on-demand decision. So as far as we're aware, there's no standards-based solution to discover where databases exist throughout a network and where specific data objects are located. And so the location of each data store is a first level discovery problem, and then the details of the database is a second level discovery problem. Next slide. So data, this is obviously a very broad concept, but we're focusing on data can be a program, a service, a resource, and we have a variety of use cases that kind of helps describe using that. And it can involve statistics, measurements, temperature, location, metadata, health records, whatever it may be. So services, you can have a firewall, and you may want to be able to find a specific type of a firewall that has certain security aspects or some other requirements, and be able to find that and then be able to utilize that. And that could also include finding CPU capabilities as well as memory. Next slide. Okay, so one of the use cases that we developed, and I'll try to quickly go through these, is being able to, when you have a SFC enabled domain, you have a variety of service functions and along a potential service path, excuse me. And the data capabilities of those devices, those service functions, it would be helpful to have them discoverable in order to steer applications based upon app requirements. We've heard from this week about using APN, and so it's kind of along the same concepts. And it's not only APN. There's some solutions outside of the IETF, like W3C, that are doing some research on application hints to the network about things that they want to declare the network to do. And part of that may be to find certain data. And so the data to be discovered in this particular instance is resources that can help a local application perform a particular task, and then data which needs to be searched and discovered to be able to provide a result to be acted upon by the application. And since this is FSC, I think Joel has a question.
Yeah, because the description you've given confuses me. On the one hand, there's already a proposal for how to do SFC, service function discovery, or service function knowledge for if you're using a distributed system, but it's aimed at making sure that the classifiers know where the SFs are, not about external discovery, because fundamentally SFC is designed for cases where the application, the thing external to the classifier function, is not choosing the service functions. There also, everybody's already using lots of mechanisms whereby controllers can just, which generally stand up the service functions anyway, can discover the service functions. So this problem feels like it's already well attacked, and I have trouble with it as an example, understanding what problem you're really trying to solve.
Yeah, so it may be, and we've talked about punting to a controller to just let the controller take care of providing whatever service function that you need to provide. And if there's already a solution to providing data capabilities of devices to applications, then that's great. Then we need to make a note of that. Maybe we can leverage that for other of our use cases. Is that what you're saying, that particular application has already been solved?
To
to the degree that I understand the discovery problem in service function chaining, I won't say it's solved completely. I mean, there's always room for improvements, but it doesn't need a whole new tack on the problem. It seems to fall well within several different domains that we know work for this problem.
Okay, Jim?
Yeah, I just wanted to respond, Joel, just quickly. Obviously, I'm aware of the service function discovery documents and stuff as that you mentioned, but I think what Mike's trying to do here is just give an example of, what type of data are we talking about? And SFC is obviously one of those, but there are many others. And, maybe this was not a bad, but maybe it wasn't the right example to use, but it kind of gives a picture that, look, there's data around there, whether it be, a particular data store or whether it be a function that's got particular characteristics of it, and we'd like to be able to discover that dynamically. So that's really the problem space.
Okay, let me be clear. I get that there's a general need to discover functions and information about them, and whether that falls into the IETF's purview or not when they're really applications is a whole different debate, and I wasn't trying to go there. But SFC, because the information is who has to discover it and who has to know it, is so specialized, seems like a bad example. And so I was really struck by the example. I'm not objecting to the underlying problem space that Mike is talking about.
Yep.
Okay. All right. Let's go to the next use case then. All right, so it could also be that applications need to discover server memory and compute resources that are available in order to steer packets towards them. One of the side meetings that happened this week was Dynecast, which I thought was pretty interesting, which is trying to discover ways that you can dynamically steer traffic to the best resource. In order to find what that best resource is, it would be helpful to be able to have data provided that gives information about, the clock speeds and, the amount of CPU cores that are available in order to, in their use case, be able to have rendering tasks diverted to those resources, including traffic and compute offloading. So this is another potential area where we have data that needs to be discovered about these particular resources in order to steer packets toward them. But there needs to be some sort of a feedback mechanism to be able to provide that information. Next use case. Okay, and this also can be included in executing a process. So in a supply chain type of an environment, let's say it's either trucks or on a conveyor belt in a factory. If you have something that needs to stay at a certain temperature, let's say a vaccine, and if there's an anomaly to that, if all that data is being sent somewhere, maybe to the edge or some other database, and there's an anomaly of a temperature that's not meeting the requirements, it needs real-time measurement data, such as, in this case, temperature, to execute a particular process. So if that data is searchable and discoverable quickly, you can steer that, in this case, vaccine to a new path to get to a hospital or somewhere where it can be used very quickly and not go to waste. And so, and this can be used in a variety of types of process execution. Next slide. The IETF loves to hate blockchain and distributed ledgers, but there is an effort that is going on, and there's a list, blockchain.-interop at IETF.org, that Thomas is leading, and he's on this draft that I'm discussing right now as well, and he wrote up this use case. The effort that is happening right now is being able to find interoperability between different distributed ledgers, which right now doesn't exist. And so there's a new protocol that's called ODAP that is being proposed to be able to have gateway-to-gateway interoperability. But aside from that, we're thinking that it's potentially a use case where you could need to be able to find data back in one of these distributed ledgers, whether it's an asset or an actual Bitcoin or whatever, and be able to have that discoverable. And so that's also, we think, a potential use case of trying to find that data and be able to have the network assist in being able to find where that data is. Next slide. And then lastly, and this is where it all started, is with edge computing. There was a variety of use cases, including using an elevator. So elevator data is, being collected on these different elevators and different floors with regards to vibration, temperature, speed, brakes, or whatever. And it would be good if that data is discoverable in order for the network and in conjunction with the app to take an action, whether it is with regards to predictive maintenance or maybe in an emergency situation where you're able to quickly identify a particular problem with a speed and be able to make a quick action on that. And being able to have that data discovered, because that data of these elevators could be stored again in a variety of places on the edge, and we just may not know where to find it. In OT worlds, they have their own contained solutions, proprietary solutions that allow them to be able to provide that information. But when you open it up to IP, then there's some new opportunities there. Next slide. So this is the last slide. So we, as I mentioned, have some problems that we've described. This draft is just trying to describe use cases that as clear as we can, and there's still work improvement that needs to be done. But the next step, and this is why we're here, would be to work on data discovery solutions, either using existing technologies and protocols. PubSub is certainly one option, and that's what is oftentimes used in the OT world. But I think we need something more robust than the existing solutions, but maybe they need to be extended. It may be silly to think about using DNS and BGP, but why not? Everybody else is extending them, so maybe there's an opportunity there. And then to see if there needs to be some protocol extensions or a new protocol needed, or maybe, as Joel kind of pointed out, maybe in some use cases there's already work being done, and we just need to maybe expand that a bit. And so, if this is a valid area that we should work on, then we think here may be the best place to do so. Otherwise, we'll continue to work on it within the IRTF. Any questions?
Yeah, as working group chair, I read all the drafts, and they seem to be a bit ocean boiling. I mean, all the data needs to be discovered by everybody, which is, not very meaningful. So the question to you, you're in routing area and routing working group. Do you plan to narrow down your use cases that they're relevant to routing specifically, and at least identify, consumers, publishers, and, how is it relevant to routing in general?
Yeah. So it's being that the next step would be to start thinking about a particular one of these many use cases and a particular set of problems, or just a particular problem. Being that we're starting to consider the solution part of this is why we're here. And so maybe there are some routing aspects to this that need to be developed, or maybe not. And so that next step, at the end of this IETF, we're going to start, evaluating now, what would be some solutions that would be able to satisfy a particular problem that we've identified. And so we're looking for some feedback from this working group.
So before I pass it to Jeff, what I was trying to say is not solutions, actually narrow down your problem statement, because it's too generic, and we are happy in routing working group to provide a place to talk about new problems, new solutions, but it needs to be narrowed down to particular set that is routing. Jeff?
Yeah, and that's understood. And that's kind of what I was trying to say. And it just depends upon which way you want to go. It's being that we're going to start thinking about, what solution may help solve one of these problems. I think that will help us narrow down the scope as we start thinking about what some of the available solutions that exist are. So the answer is yes. We're going to start narrowing it down and seeing if and where this may be able to be benefited by a routing protocol, or that a routing protocol can help solve. Jeff?
As Juniper. So I tend to agree with prior comments that this is trying to boil, very large sets of oceans. But the two general oceans that I think are the interesting ones are you're looking at a general directory/discovery service to figure out what are the interesting things I want to get. And over your use cases, you're getting once I've decided I'm interested in something, how do I actually get it in an efficient fashion that makes sense for the data? Is it something that needs to be sequenced reliable? Is it something that I'm willing to get a periodic unreliable telemetry stream for? And certainly the second piece of things is where IETF has good technologies for that sort of thing. We don't really have the sort of dump truck subscription directory. A thing from past history that I have very cursory exposure to is Corba, where you have basically objects in the system that you may want to get state for, and a directory mechanism was created to be able to get to the stuff and to publish that you have such things. So I think that directory stuff may or may not itself be within the context of IETF. The other items, you have to decide what the properties are you want and decide if you actually have good distribution mechanisms that are fits for technologies we already have.
Okay.
Okay, thanks, Mike. Fan Yang, your turn.
Thanks.
Okay, thank you. And this is Fan Yang from Huawei. And in this draft, in this draft, we introduce an associated channel over IPv6. And for short, we name this associated channel as ACH, and we limit the scope to IPv6 networks. Next, please. Yeah. The higher level motivation here that we see from IPv4 to MPLS and from MPLS to IPv6, the IPv6 provide the connectivities in many cases, many new use cases, including the legacy networks, and also there's new emerging use cases. And for in all these scenarios that we recognize that IP services requires higher quality of RSA guarantee. And we see segment routing over IPv6 provide the optimized route for service forwarding via the routing programming capability on SRH. And so this ACH is proposed to provide the control and management programming capabilities for the service forwarding. And later we will have some examples at the end of this slides and to show the applicability. Yeah. Next, please. See that and this slide describes the architecture of the ACH, and in middle of there's a cloud in middle, and it shows it is an IPv6 network, and the black line between the first node and fourth node represents the IP path, and user data is transmitted along this IP path in the yellow arrow. And you see the blue arrows are the associated channel created to the IP path. And sorry. And we see in the right bottom graph, and it shows where this ACH is where this ACH is in one network node, and the control and management plane generates the control and management messages, and it is in sorry. And it is carried in the associate channel and transmitted in the data plane. So to sum up, the ACH is a control channel, and it is an associate channel to an IP forwarding path. It carries the messages of the control and management protocols to provide the control and management functions. Next, please. Yeah, in this draft, we specify the ACH as a TLV format, and the type specified it is a control channel for one specific IP path. The channel type specifies the type of the control or management protocol. To identify the IP path, and also associate the IP path to the ACH, an associate channel ID is specified. And the messages of the control or management protocols are carried in the fixed message field. And since it is a TLV format, so this ACH TLV can be encapsulated in IPv6 extension headers. And it can also be encapsulated as a payload in a systatic packet. And later I will give two examples to explain the applications, to explain the end-to-end and hop-by-hop applications. Next, please. Okay, the first use case is we call it unified OEM. Here we give we list three protocols used for the OEM functions, and we also identify there are several problems there because different protocols are fulfilled different OEM functions, but they also have functions overlapped, and all of this they use the independent session identifiers, and they are deeply encapsulated in IP packet. If there is any intermediate node on the path, they are not sensed, they are not aware by the end-to-end sessions, OEM sessions. So here we try to come up with a simple solution to carry the different OEM messages in ACH in the IP layer and also in a uniform way. And the advantage is to reduce the number of the OEM protocols and reduce the number of the sessions, and also unify the session identifier. The figure below shows there is a end-to-end OEM end-to-end ACH how an ACH TLV is used for the end-to-end session. Here there is a delay measurement type of ACH TLV is encapsulated in the IPv6 DOH header, and this E2E should be replaced with DOH. And with the ACH associated ID, and when R4 receive this packet, and the ACH will be receive this packet, and the ACH it will process the ACH TLV to measure the packet delay. Next, please. And the second use case actually used two associate channels here. When the first ACH channel is used between from R1 to R4. So R1 generates fault management type ACH TLV and encapsulated in the IPv6 hop-by-hop extension header. So in this way, that the every node on this IP path will be process this ACH-TLV. And for example, if there is an error detected on R3 node, and when R3 node process this ACH-TLV, it will update the ACH-TLV to set the flag of this arrow, to indicate this arrow, and send to R4. And on R4, it will use another ACH-TLV to indicate this fault or this error back to R1 to ask for the switchover of this user data forwarding. And the second ACH is actually should be it is used for the end-to-end session, because yes. And next, please.
Okay, I wanted to point out there's someone in the queue, so you can choose to take his question or wait. It's up to you. But I just wanted to point out that Greg is in the queue.
Yeah, no, it's okay.
Okay,
Please,
go ahead,
Greg.
Sorry to interrupt.
Mm-hmm.
Well, that what in the previous slide being presented, it looks as a combination of two processes. First is failure detection end-to-end, and second is protection switchover coordination using RDI functionality, remote defect indicator. So, and this is not a new problem, and this has been solved specifically using combination BFD and protection switchover coordination protocol already. So that's one note. But my general question is other one, that UDP is becoming predominant transport. So why not OEM on UDP transport, and why you're proposing to do it on IP? Because it's not guaranteed that IP and UDP will be transported in the same manner, and they will experience the same treatment from the network.
Yeah, I will first answer the first question. You mentioned that there, yeah, I understand what you have described, but there is one case that the BFD and its RDI indication is not exactly solved. Is if this error is not a failure of this link, if this error is just a signal degradation, so they will be. There's no if there is only the signal degradation, so the BFD cannot 100% to detect this function, detect this error. So that is actually this error. This case is the case that we think that the current protocol
okay.
cannot solve.
It's great that you mentioned this scenario. So basically, what's in constant bit rate media called errored seconds or severely errored seconds. I hope I will have a presentation time in IPPM working group, which is in parallel to Rtgwg. I don't invite everybody to switch there, but it's been scheduled, and you can look at individual draft in IPPM working group on error performance measurement. And that addresses, I believe, your scenario. So basically, in combination of how network failure, packet loss, and delay can be combined together and expressed as a single metric.
Okay, thank you for the pointer. I think I will look into it, and maybe we can better discuss it in the mailing list later. Yeah.
Yes, of course. Thank you.
Thank you. Yeah. After we send this draft, we update this draft and we receive some comments. And I want to give the feedback to the comments. And that first, we first borrow this. Yes, we borrow this idea from the MPSG SAH, and also the second is we define this this ACH ingress node and the egress node, and so this ACH TLV will be encapsulated in at the ingress node. That means the first node of the IP forwarding IP path. So there will be no confliction to the RFC 8200. Yes, and currently the scope is defined for IPv6. Maybe there are some suggestions that we could start to focusing on the ACH, how ACH can be used for on SRv6. So we will consider this. And yes, the ACH is designed for IP layer and encapsulated in IP layer. Yeah, I think I will also reply this reply this question from Greg in the mailing list later. Next, please. Yeah, the next step will refine this draft based on the comments and suggestions, and maybe yeah, and start the application. Start to specify how the applications used by ACH. Yes, used in with ACH. Yes. Yeah, that's it.
Okay. Thank you. If there are, we'll give a moment for anyone to come to the mic for questions, but okay, thanks. Shall we move on to Cheng Li presenting?
There have been a number of comments and some discussion on the chat. Please take a look. Mostly comparison to FTP, but you know, for educational purposes.
Can you hear me?
Yes.
Yeah, perfect. Okay. So basically, my topic today is about IPv6-based cloud-oriented networking, and we call it CON. Next, please. Hello. Next.
So I've advanced the slide. It shows motivation on top. I'm not sure if it's reached you yet.
Yeah. Sorry, I get it right now. So
okay, thanks.
The motivation, yeah, the motivation of why we propose IPv6-based CON is that, as you know, with the development of cloud computing, right, the connections between the enterprise network side and the cloud, especially like the third party public clouds, are added. So it will introduce some new requirements and challenges for to the existing networks. And as you can see that the draft net to cloud problem statement has described some problems and challenges that the existing network facing today of how to handle the interconnection between the enterprise branch offices and the third-party clouds with the dynamic workloads in their VPN, right? And also in this document, we also describe some extra challenges, such as we know that if you are using the option A in the Intel AS, right, it is really hard, like to configure the VPN, right? So the second one is that if we are using the VXLAN to connect the different branches, and as you know, we cannot specify the underlay forwarding path because the VXLAN is only like overlay protocol, right? So the strict TE requirements like the deterministic delay and like specific path forwarding, something like this, they cannot be guaranteed, right? So in order to address this kind of issues, we propose IPv6 based cloud oriented networking. So in this document, we describe the challenge of the networks facing today, and we also list the requirements that IPv6 based CON should satisfy, and we also list some like candidate solutions. Yep, next please. So overall, IPv6 based CON is a networking architecture that first of all, it is a IPv6 based networking, right? And secondly, it is designed for the cloud. Yeah. So this slide describes the problem statement of the existing network. Basically, we have two parts of this slide. The first one is the underlay. And as you can see from the figure 1, we draw a typical telco cloud topology right here. We have edge DC, we have remote region DC, and we have core DC, something like this. And how to deploy the quick connection from end to end, even travel multiple like data center. It's a really how say critical issue for us right now. And sometimes we need to deploy like service function chaining within the like edge DC or the GI lane, something like this. So you know, it's really hard to support SFC in the peers networking right now. And regarding the overlay part, we describe a typical scenarios, which is SD1, right? In SD1 scenarios, sometimes we will use the VXLAN to connect different like signs and between the POP gateway, something like this. But in this case, the strictly like this kind of requirements cannot be satisfied, right? So next. Some delay, right? So this kind of requirements are listed in the draft, like quick connection, hybrid network connection, pass programming, something like that list, right? And as you can see, resource assurance and service function chaining, performance measurements, they should be supported in IPv6 based CON, right? Next. So in order to satisfy this kind of requirements, we also list some candidate solutions in this kind of aspect or use case, like VPN, or path programming, service function chaining, and network slicing, and on-path measurements, and reliability security, something like this. Next. And I will go really quick to go through the whole requirements and solutions to make a quick picture for us, for all of us, right? So for quick connection, as you know, the clouds were located in any location around the world. So and the people will try to connect the cloud in anywhere, anytime. So we need to provide quick connection between this kind of like VPN sites. So VPN SRv6 may be a like good candidate solution, right? Next. So this is about a hybrid network connection. As you know that the connection between the clouds and the enterprise sites may travel multiple types of networks such as IPv4 and MPLS and SIP6, IPv6, something like this. So we have to support end-to-end like IPv6 forwarding at least. And if possible, if we can support end-to-end SIP6 forwarding, that would be best, right? And in order to interworking and with between those kind of different type of networks, we need solutions for stitch the paths between like SIP6 domain and SIPS domain and IPv4 domain, something like this. And GSIP6 provide a candidate path, a candidate solution for addressing this kind of solution. Yeah. Next. Yeah, path programming. We don't need to say too much. Like we need the traffic to be forwarded following the specified path. Yeah, so candidate solution could be like SIP6 or SIPS, but in this draft we say that we need SIP6 because it is IPv6 based networking. Next. Yeah, regarding the resource assurance, we think network slicing mechanisms are really needed, such as VPN plus. Yeah, maybe we can add more solutions into this draft. So, and this draft is really a beginning of the draft. So we need more comments and we need more contributions and welcome. Yep. Next. Yeah, this is about that deterministic delay. As you know, some applications need the really low latency, right? So the solution could be like DetNet or TSN. Sorry for the typo. Yep. Next. Yeah, this is about service function chaining, and typically the SFC can be deployed without within the cloud data center or the GLN data center, something like this, right? So we think the SIP6 based or IPv6 based SFC has to be supported within the IPv6 based CLN, right? Next. Yeah, so performance measurement is a basic requirement of any network. So there's nothing special here. And we suggest to use the in-band PM or on-pass PM, anything you can call it. And for example, like IPv6 alternate marking or IFH, IOM, something like this. Yeah. Next. So this part is about the reliability. We list some solutions such as BFD for end-to-end protection and FR for local protection, like the midpoint protection, egress protection, something like this. And we also, as you can see, that we have some work of redundancy protection. So we also include this kind of protection mechanism in this draft. Yep, next. Linda, I will go through the whole slides very quick and you can ask later. Yeah, thank you. And this part is about security, nothing new here. And I think we should not introduce any new kind of security issues, threats into the CON. Yep, next. Yeah, this part is about the forwarding efficiency. It is really important because, you know, in the multi-tenant scenarios, the tenants will run like, for example, a link slide, right? In this case, the forwarding efficiency for the tenants will be very like important, critical, right? So we provide two dimensions of solutions to address the forwarding efficiency issues. The first one is we have to discover the path MTU along the path, so we can set the appropriate MTU for the packet, right? And the second part is that if we are using the SRv6 for forwarding, the compression mechanism should be applied, such as GSRv6. And by the way, we have over 10 vendors have support GSRv6 right now, and you can see more news in the near future. Yep. Next. So the last one is application-aware networking. Yeah, in IPv6-based CON, we will have many types of application traffic, right? So they will have various queues requirements. So we should provide fine granted traffic steering mechanism for this kind. For the traffic. So we add APN6 as a candidate solution here, and if you have more like kind of solutions, welcome to discuss with us. Yep. Next. Yep. Next step. Welcome to comments, Linda, and we are looking for more collaboration on this draft, because it is really a beginning of this draft. And if you have more mechanisms, solutions, welcome to contribute to the draft. Yep. Thank you. Next would be thank you.
Okay, thank you very much for the presentation. So I have a couple of comments. It seems to be this draft covers a lot of things, and it seems that all the network technology developed by IETF is under this scope, okay? But I feel it's too big. Maybe it's better to break the draft into some smaller ones. For example, when we talk about cloud oriented networking, right? So if we talk about public cloud, then you're bound to have longer distance because public cloud data centers are far apart from the enterprise, and that technology needed for that is quite different from, like, say, edge computing. Like, for example, in the 5G edge computing environment, where the mini data centers, well, they also call cloud, are very close to each other. So it's a local data network. It's a smaller domain. Like for mission critical applications, you may need that net to be in place to guarantee the delivery, right? And so that with each domain, different domains, you may need apply different things in there to make it the draft more concrete. Okay, this is this particular domain. For this domain, we need technology 1, 2, 3, 4. For the other one, we need 3, 4, 5, 6, something like that. I think will be better, easier to focus.
Yeah, excellent suggestion. We'll follow up with you. Yep.
Ron, please go ahead.
Hi, Ron.
I'm trying to figure out what the ultimate goal of this draft is. Are you building a network architecture for network operators and cloud providers to implement, or are you suggesting the development of some new routing mechanism? Then, if the former, is this the right forum in the routing area working group? Yes, if the former, is this the right venue? Or maybe is it something that should be in the ops area?
Okay, so Ron, as you can see, this is the architecture draft of CON. Right now, we were trying to find the gap of the CON and existing networks, and we have at least some existing results right here, right? And we need more input to find where's the difference between the CON and existing network. and maybe we can find more like gap right there, and we get more new mechanism to address this kind of issues, and we will need more mechanisms.
Well, then the question
Hello?
goes to the chairs and the ADs: isn't that like an ops area thing?
I cannot answer your question right now because I don't have the answer correctly right here. So maybe we can discuss of like.
I mean, so in general, you know, we use the routing area working group as a sort of open discussion platform. So, you know, it has a pretty low threshold for presenting material, but a significantly higher threshold for adopting particular drafts. So
okay, fair enough.
We're not really talking about it. You know, I don't think, you know, we're really in the context of adopting it yet. So, okay.
So Alvaro could address the 3D from my perspective, same comment as the previous presentation. Please try to narrow down your problem statement, because as of today, it's just trying to boil the ocean.
Yeah, sure. Thank you, Jeff. Thank you, Jeff.
Sure. And now we've got
thank you, guys.
Shusang. Thank you.
Have a good day.
Shusang?
Okay. Yep, I'll switch the presentations over.
Thank you.
Give me a moment. Okay, it should be ready.
Okay, let's go. This is the last presentation, and I won't make it too tough. This is Xue Song from Huawei, and I will introduce our work about SRv6 middle point protection. I noticed Ron is raising his hand. Do you have any question for this presentation?
Put it down from last time.
Okay. Okay, thank you. Next slide, please. This is the outline of this presentation. The motivations and goals will be introduced. And because this document has already been presented in IETF for maybe this is the third time, so the mechanisms and the security considerations has already been discussed before. I will go through briefly this time. And I will give some response to the questions we have already received in the working group. Next slide, please. So why we need SRv6 midpoint protection? In a SRv6 network, when an endpoint indicated in the SRv6 policies failed, the existing FR mechanisms, for example, TILFA, also defined in Rtgwg, can't protect the failed node because the current IPv6 destination address is pointing to the failed node. SRv6 end-to-end protection with EFD could work in this scenario, but local mechanisms which is faster and easier to deploy is also requested. There is another document in IETF that has already defined the endpoint protection mechanisms used in SRMPS network. And this document introduces an endpoint protection mechanism with that could be used in an SRv6 network. We call these mechanisms SRv6 proxy forwarding. Which means when an endpoint of SRv6 policy fails, SRv6 proxy forwarding node, or we can call it repair node, could replace the failed node to perform SRv6 end function. Next slide, please. So what is the mechanisms in detail? when we define this in two cases, when the repair node is adjacent to the failed endpoint, the repair node excludes the behavior defined in the pseudoware showed in the picture here. If the active segment is not the last segment in SRH, first decrease the segments left by one, update IPv6 destination with the next segment, or some segment after the active segment in the segment list, and fib lookup on the updated destination address and forward packet according to the matched entry. You can notice that this is almost the same as the AND function defined in RFC 8986. If the active segment is the last segment in SRH, there is no next segment in the list, so just forward packet according to the backup next hop. When the repair node is remote, sorry, not yet. There's another scenario when the repair node is remote to the failed endpoint. This case will happen when IGP convergence has already happened, and the repair node excludes the similar behavior as the just introduced above. So next page, please.
Okay, thanks. I apologize for the previous one. I got tricked by next hop. So.
It's okay.
Okay.
In this document, we introduced section 5 and section 6, which section 5 is about determining whether the endpoint could be bypassed or not. The section 6 is security considerations. Both sections could be used for security guarantee. In section 6, the document requests the required node and the failed node must belong to the same trusted domain, which making the SRH could be changed safely by the repair node. In section 5, the document requests to ensure the security-related segments can't be bypassed by the proxy forwarding, even when the corresponding node or link is failed. So, but the mechanisms requested by this scenario is defined in another document, and the draft ID is listed here. Next slide, please. Here, we list the questions that have been received since last IETF. All these questions have already been answered in the mailing list before. Just to discuss these questions in the working group again, we think this is necessary and meaningful. The first question is how to differentiate whether the failed node is the failure is node down or link down. Generally, link failure and node failure are both treated as node failure in this document, just as our FIR mechanisms. The second question is about what function of the failed node could be excluded in the repair node. Because the proxy behavior is for path repair, which only guarantees the reachability. So other functions can't be replaced or proxied, only the end function is excluded. The third question is, could TE path be changed when doing protection? Actually, this is a very general question. We believe the middle point protection is a temporary status. So it's just for a temporary reachability repair when failure happens in the TE path. If SLA of the TE path is supposed to be guaranteed during the process, end-to-end protection could be considered. So it's another story, maybe after the local repair happens. Next slide. We believe this document is stable and the mechanisms clear. All the questions have been discussed in the working group. Maybe there are further considerations afterwards. But in the existing stage, we think the document is ready for working group adoption, and also welcome comments and questions. Thank you.
Bruno, please go ahead.
Bruno is speaking as Spring co-chair. So the scope and the goal is very Spring specific, because it exists only because you have a list of segments. Then the mechanism is a bit heavy on SRv6 SRH handling. And third point, we have in Spring we have the working group document with the same scope for SR and PLS.
Yes.
So all in all, I think it would be better to discuss it in the Spring working group.
Yes, this is a very good question.
Have you
Sure,
discussed
go
it
ahead.
on the Spring mailing list, or I haven't seen any email in the list?
Actually, this is a topic we have discussed before with other authors. We are a little confused now about where to discuss this document. Actually, because this document has been discussed in Rtgwg several times, so in this stage, maybe we prefer to put it here. Although we also believe Spring is another good home for this document, but we are also willing to present the mechanisms to Spring if necessary. But considering, for example, TI of A is also defined in Rtgwg, and this document is informational. It's just about the forwarding behavior, considering the local repair. So also we would like to hear the chair's advice. Bruno, your advice is really helpful, and maybe some discussions about the document's home is deserves more discussion.
Yeah, I mean,
if I may interrupt here, I believe we had intentions to meet and discuss. There are about 6 or 7 different drafts on midpoint endpoint protection that are being discussed between Spring and Rtgwg. Bruno, should we take an action point to actually meet between this IETF and next IETF and discuss all those drafts?
Sure. We can, yeah, sure.
Okay, so Shushan, let's postpone your question till after we have discussed and possibly we could agree on home for most protection drafts, and that would be a guideline for further development.
Okay, sure.
So I would say up until this point, your work has not been in vain. You know, it's mostly the same people attending this meeting as attending Spring as well. And so any discussion that you've had, it's not like you'll have to like start over. You know, it's already been a useful work, right? But if I mean, it's a positive thing to have the Spring working group chair say that he thinks it should be over in Spring, because at least that means he thinks it's important work. So it's a
Okay,
I wouldn't be
thank you.
discouraged by this development.
Thank you. Really happy to know that. Maybe have more helpful discussions in in Spring also. Sorry.
As Chris said, the looking at people overlap is probably 70–80%. So anything said here is useful for Spring.
Sure.
Do we have any other questions, comments, wishes? Okay, I think we can close this IETF, and we hope to see you all virtually in San Francisco in 4 months from now. Thanks, everyone. Have a great day.
Thank you.